Chapter 4, Section 3, Question 1. Word problems again. Word problems with angles. And we think, gosh, we just did word problems with angles back in Chapter 2. Complementary are two angles whose sum is 90 degrees. We did that back in Chapter 2, and they don't have to be next to each other. They just have to be two angles whose sum is 90 degrees. Supplementary angles are two angles whose sum is 180 degrees. They don't have to be next to each other either. Angles A and B are supplementary. According to that, angles A and B are supplementary. We could actually use the letter A for angle A and the letter B for angle B. And angles A and B are supplementary says that if we add those together, we will get 180. But wait, there's more. The difference of angles A and B is 47.4. So if we have A minus B, we will get 47.4. Elimination is amazing. If you look, they're all lined up. Instead of x's, y's equals number, it's a's, b's equals number. A plus A gives us 2A. The b's will cancel out. And then, if we add going down, now be very careful. A lot of students see a larger number on top, a smaller number on the bottom, and they accidentally subtract. We are adding going down. We are adding a positive b and a negative b. And that's why we get 0. Now, as we add this up, if you need to, put in a plus 0 here to make sure everything lines up. And then divide both sides. But wait, there's more. We need to find B. So, because we have two variables, we have to find two answers. Here's A. The easier equation would be this one. It has lots of positives. So we have 113.7 plus B is equal to 180. Hey, now we really are subtracting. So we do need to have this 0.0 here. We're going to have to borrow and borrow. Keeping those decimal points all lined up. And now we have variables. Write the equations, solve it, plug and solve it, and then write the answers. A is 113.7, B is 66.3, but you don't get full credit until you label them. Chapter 4, Section 3, Question 2. You'll see a lot of versions of this. You'll have boats in a river that has a current. You'll have planes flying with or against the wind. You'll also have things like Superman flying for or against the wind, or with or against the wind. So keep in mind what is reasonable. All right, Superman travels very fast. All right, plane speed and wind speed. Many students will use P for plane and W for wind. I have seen some students who are like trying to be tricky. They use W for plane and P for wind. Then they get themselves confused and they get the answer wrong. It's not worth it. If you don't want to use P and W, use X and Y. So the first sentence says that the plane flying with the wind travels at 415 miles per hour. Then the next sentence says the plane flying against the wind travels at 350 miles per hour. So the plane's speed is somewhere between there because with the wind or against the wind. With the wind, a tailwind will make your plane go faster, and a headwind fighting against you will make your plane go slower. P plus P is 2P. Positive W plus negative W will give you 0, and then make sure that you're adding. Because remember from last question, a lot of students see the larger number on top, smaller number on the bottom. They think that they just subtracted, so then they start subtracting here, but we need to add. And then divide by 2. We found the plane speed, but we also have to find the wind speed. You could plug it into either equation, but the one that has all the positives, that's going to be a little bit easier. Notice all these decimals. Decimals, yet fairly nice decimals. That's what I would expect. We need our point 0 so that we can borrow. Keeping those decimals lined up because we're adding or subtracting. Take a look, does this make sense? A plane, in order to stay aloft, a plane needs to be going fairly fast. This is why our cars do not generally fly. So our plane is going over 300 miles an hour, and the wind speed is about 30 miles an hour. In a hurricane, winds go like 100 miles an hour. So the students who accidentally subtract here will have a plane that goes 32.5 miles an hour in winds of 382.5 miles an hour. They're not even on Earth. They're somewhere else. It's crazy. Besides, why would you be flying a plane in 300 mile an hour winds? So please make sure that these answers make sense. Our plane is going 382.5 miles per hour. Make sure you label. And the wind is going 32.5 miles per hour. If it gets too much faster than that, you might not want to be flying. Chapter 4, Section 3, Question 3, Mixture Problems. We had mixture problems back in Chapter 2. We have mixture problems in Chapter 4. We'll have word problems in Chapter 6 and Chapter 8. Every other chapter we will have them. So our mixture problems, we want to make our handy-dandy mixture chart because that helped us out a lot. Eventually, you might not need to make a mixture chart, but if you're making mistakes, I really want you to have them. Now, all of our rates and per things I put in the center. So in this case, we have per cents. We have our starting amount, which is, we're going to start off with cups. And then it's going to be amount of bleach. So a student needs 3 cups of 20% bleach solution. They don't have 3 cups of 20% bleach solution. This is the mixture that they're going to be creating. It's going to be 3 cups of a 20% bleach solution. Remember from Chapter 2, we don't want to put a percentage into our equation. We want to put it in as a decimal, almost always. If you always make it into a decimal, it should always work on these problems. There are some where you don't have to put it into a decimal, but until you understand when it's appropriate to do it and when it's not, let's make them into decimals. A student has a 10% bleach solution, and they have a 50% bleach solution. Again, make those into decimals. Remember the 0 in the front. How many cups of each are needed to get the desired solution? If you remember, back in Chapter 2, we used x and 3 minus x. You could still do this, but I'm going to show how to do this using elimination. When we were using x and 3 minus x, we were actually solving this using substitution. Now we can use x and y. Coming over here, x and y. 10% and 50% solution. If you remember, going down, we added. That gives us an equation that says x plus y equals 3. As we go across, we multiply. And that gives us 0.1x, 0.5y, and 3 times 0.2 gives me 0.6. And as we go down, we add to equal this, and this is our other equation. Just like in Chapter 2, I'm putting a wiggly box around this because the variables and the equation, that's half credit. Now, I notice these decimals. I want to get rid of the decimals. I'm going to multiply everything by 10. So, that will give me x plus 5y equals 6. And if I take this, I have x plus y equals 3. Now, I want these x's to cancel. I want one of them to be negative. Do I want to have 5y minus y or y minus 5y? I would rather have these change signs. So what I really did to get from here to here is I multiplied everything by -1. To get from here to here, I multiplied everything by 10. Bar. Those cancel. 4y equals 3. Ooh, careful. Dividing by 4 on both sides. I get y equals 3/4. If it makes you happy to make it y equals 0.75, that's fine. And then we're going to plug it into one of the equations. I don't know about you, but I think this is a much simpler equation. So we get x plus 3/4 equals 3. Subtract 3/4 on both sides. I'm going to make common denominators. Hey, we're using common denominators a lot. That's preparing us for chapter 6. That gives me 12/4 minus 3/4 for a total of 9/4. I have my x's, I have my y's. If you want to make this into decimals, totally fine, because usually, people have 3/4 of a cup, and that's fine, or 0.75 of a cup. Most people would have a hard time measuring out 9/4 of a cup, but you could do it as 2.25, 2 1/4 cup. And then here, we put the answers here. Do make sure that the x one goes on top, so 2.25, labeling it with cups, and 0.75, labeling it with cups. Variables, write the equation, solve it, write the answer, and label it. Chapter 4, Section 3, Question 4. This is really why we have standard notation. So this has happened before, where people go out and they buy stuff and they come back and we're like, hey, how much do we owe you? Oh, I don't know, I lost the receipt. Somebody else, it's like, hey, you also went to the same store. How much did you pay? I don't know, I lost the receipt too. We can use math and find out how much the burgers and shakes cost at this restaurant. I will tell you that at my restaurant, everything costs under $10, because I've seen some students who have $300 burgers. I will sell them a burger for $300. All right, here we go. So our burgers and our shakes, we can use B and S. Some students don't want to use S because their S's and their 5's get them confused. You're welcome to use X's and Y's. So 6 burgers and 4 shakes cost $32. 6 burgers and 4 shakes cost $32. That is a very easy English to math sentence. 5 burgers and 2 shakes cost $23. That is a very nice and easy half credit, but we're not going for half credit because half credit is an F and no one should be aiming for an F. Now, elimination. I told you elimination was probably going to be used a lot more than substitution. Some students want to use substitution. I'm going to suggest you don't. So we need to get rid of one of the variables. 6 and 5 meet up at 30. 4 and 2 meet up at 4. I don't know about you, but I'd like them to both be 4. That is a much smaller number. So nothing's going to happen to this one. It already has a 4. To get this to be a 4, I'm going to multiply everything by 2. I'm going to multiply it in my head. If you need to show the work, you can. But we're going to multiply everything by 2. We're going to get 10B. We're going to get 4S. And we're going to get 46. Now, these are not going to cancel out because they're the exact same signs. Do I want to do 6 minus 10 or 10 minus 6? I would rather have bigger number minus smaller number, so I'm really multiplying this top one by -1, and that will change all of their signs. I do that afterwards because some students decide at the beginning, and then sometimes they end up with negatives, they get themselves confused, they come up with negative numbers of burgers. That doesn't make sense. So 10 minus 6 gives us 4 burgers. The shakes cancel out, and 46 minus 32, 46 minus 32 gives me $14. Divide both sides by 4, and we get that the burgers cost 14/4 will reduce to 7/2. No restaurant is going to charge you $7/2, so therefore it might make more sense to make it into 3.5 so that later on we can have $3.50. Now, I have to take my burgers and plug it into one of these equations. I'm going to pick this one because I'd rather divide by 2 than by 4. But remember, it doesn't matter which equation you pick because math. All right, 5 burgers and 2 shakes costs $23. Our burgers are $3.50. $3.50 times 5 is $17.50. One decimal in the question, one decimal in the answer. We're solving for S, subtracting on both sides. Our point zeros. Borrowing. Dividing. $2.75. This is a very reasonably priced restaurant where our burgers are $3.50, our shakes are $2.75. Do make sure that as you write the 3.5, you make it look like money here in the United States, and our money has 2 decimal places. Chapter 4, Section 3, Question 5, Type 1 of 2. We're going to have percents and y equals mx plus b. We're reviewing our slope-intercept form from back in Chapter 3. Now, this has actually happened to students. Long ago, there was a company here in Colorado Springs where they actually hired high school students, did not pay them what they were supposed to, and you know how students have lost their homework? They lost the piece of paper that said how much they were supposed to be earning. Then, when they were like, I have worked a lot of hours and this is all I got for my pay, it doesn't seem right. And then we had to go and calculate how much they were supposed to be getting paid based on what they remembered. And then it was up to them to talk to their HR department, to argue with their bosses, or just to quit because they were routinely being paid under what they were supposed to be paid because they didn't have the paperwork to back it up. And because it was a company that was essentially cheating our younger students. So over here, let's take an example of a weekly wage and commission to go over how commission actually works, because a lot of students haven't heard about working on commission. Let's say that the company offered you $250 a week to work for them, and then they offered you a 20% commission on everything that you sell. If you sold $1,000 worth of stuff for them, then 20% of 1,000, 10% of 1,000 would be 100, 20% of 1,000 would be $200, plus the 250 they originally told you that they were giving you, and that would equal $450 that you would get for that week as take-home pay. So if you sold nothing, you would get $250 a week, which is not much. But if you work hard and you sell the things that they want you to sell, then you can go home with more. And if you're selling 3,000 and 4,000, wow, you're going to be taking home a lot more money. This comes up with our equation, which is our weekly wage, which we don't know, plus our percent, which we don't know, times our sales, which we're told, equals our earnings. So we don't know this and we don't know that. Our weekly wage we could put as W. Our commission, which will be a percent later on, we could use C for commission. So our weekly wage plus our commission times $3,000 is equal to $500. Now I've had a number of students who are not comfortable with it written like this because the coefficient is after the variable, in which case, hey, we can use the commutative property and switch the order around. That's perfectly fine. Then we don't know what our weekly wage is, but we sold $4,000 at whatever our commission amount was, and we got $600. That right there. We have our variables, we have our equations, that's half of our grade. Right there, we want to make sure that one of these is negative, because we have two positive W's and we want to use elimination, we want to get rid of one of those. Would you rather do 3,000 minus 4,000 or 4,000 minus 3,000? I'd rather have the larger one be positive, so I'm going to multiply everything on the top by a negative. That's to remind me, so I'm going to have a negative W, a negative 3,000 C, and a negative 500, and positive W, positive 4,000 C equals 600. Bar, putting them together, those cancel, 1,000 C equals 100. We're dividing both sides by 1,000. We could reduce that and we could get 1 over 10. But C is supposed to be a commission, and commission is supposed to be a percentage. So we might want to make that into a decimal so that we can then make it into a percent for our answer. Whew. We're not done. We still have to find our wage. So some of my students said, but I was supposed to be paid 20%, I thought. Well, find the paperwork, talk to your HR department. Now we're going to find this. Either of those, not bad. I'm going to take the top one, W plus 3,000 times my 0.1, because remember when you plug it in, you want it to be a decimal, is equal to 500. Timesing by 0.1 moves a decimal over one place, so we get 300. Some of you might already know how much this person is getting paid each week. But we're still going to show the work because algebra. They're getting paid $200 a week, and they're saying, oh, but I thought I was supposed to be paid $250 a week. Oh no. So this person is getting paid $200 a week, and then they're supposed to be getting paid 10% a week, and that is what we have found out. Chapter 4, Section 3, Question 5, Type 2 of 2. We are going to compare two things. This is a useful type of problem for real life. Often you're going to find that it's not quite this basic, but we're trying to show you how you can use math to compare two plans. So we have a gym that offers two types of memberships. Offer 1 is $1.50 per visit, and offer 2 is $8 per month plus 50 cents per visit. I'm going to take this one and make it into y equals mx plus b. You might think of y equals mx plus b as slope and the y-intercept. But I also want you to think about it as y equals change x plus start. That is what's going to help us on this. How much did it change each time? 50 cents per visit. It changed by y equals 50 cents per visit plus the starting amount of $8 a month. Here, y equals, it changes by $1.50 per visit, and it started off with $0, which adding 0 by the additive identity, we don't have to write. Sorry, I wrote that backwards. Now, what do we have here? This change is in dollars per visit. Think about this as slope. This is rise over run. And if you remember, that was y2 minus y1 over x2 minus x1. The y's are the rise, are the dollars. The dollars are the cost. This is your y. The number of visits is on the bottom. That is your x. Folks, that is your cost, and it's equal to 50 cents times the number of visits plus $8. This is your variables in your equation. Now, some students put y here and x there, in which case you would have to switch these and have an x here and a y there and an x here and a y there. Otherwise, you're going to lose at least a half credit on this. So be careful about this one. Now, if you notice, I have a letter and an equal sign. I have a letter and an equal sign. This is a wonderful place to use substitution. We have been using elimination a lot. So I can take this and substitute in for y. I can take this and substitute in for y. Either way, I'm going to put this one on this side. $1.50 x equals 0, that's an interesting 0, 0.50x plus 8. Because they're both equal to y, they're both equal to each other. I'm going to subtract this over. Leaving us with x equals 8. Hey, at x equals 8 visits, these will cost the same amount. After how many visits will the offers have the same cost? After 8 visits. Now, the question is, how much does it cost? I can plug it into either one of these, but this just has a single multiplication. This is a multiplication and an addition. I am going to pick that one. Y equals $1.50 times 8. So we have visits is 8 visits and costs $12 to go to the gym.